Good morning, everyone. In this session, I'm going to continue about the last session, that is coefficient of determination, that is R squared. So this is the coefficient of determination is a measure that provides information about how well it is going to fit a model. And that is R squared. And we also discussed about the formula how we are going to find out this R square, that is 1 minus sum square regression by total sum of squares, which is given by sigma yi minus yi cap whole square divided by sigma yi minus y bar whole square. Now, let us discuss this particular R square, how we are going to calculate this R square with the help of one example. And this also we discussed, like what is the difference between R and R square, and if how much distance between actual value and predicted value. I hope you remember all these points. Now, let us solve this one worked example. See, this is below is the graph showing the number of lectures per day affects the number of hours spent at university per day. So the equation of the regression line is something this one we already drawn on the graph, and it has equation already. Equation is being defined here. In the earlier example, we only found out that this b naught plus b1 into x, okay, where we are going to find out the predicted value. But here already they have given the expression, and they are asking us to, they already given this equation of the regression line. They are asking us to calculate the R square. Let us see how we are going to calculate R square for this particular equation already being given. So to calculate R2, we need to find the sum of the residual squared. Remember this, sum of the residual squares by the total sum of the squares. Okay. Now we are going to start by finding the residuals, which is the distance from the regression line to the each data point. Okay. How we are going to find out the residuals is the data point to the regression line, the distance if we find out, then we will come to know what are these residuals, that is errors. Now, see here, in this particular graph, we have here 2 and 2. One point is 2, 2. One is 3, 4. One is 4, 6, and other one is 6, 7. And already told you in the earlier classes, the data points below the regression lines, it shows a negative sign. The data points above the regression lines shows the positive sign. Let us see, by calculating these particular residuals, will be satisfy this condition, like below this one, whether it is having negative sign, and above this, it is having positive sign or not. So our data points are 2, 2, 3, 4, and 4, 6, and 6, 7. Let us calculate for these points. Now, the very first one is for the point 2, 2. Okay. Y cap, that is prediction of y. Already we know that this equation is being given. So in this, just place the value of x. In this, one value is x. Okay. X comma y it is. Okay. X coordinate and y coordinate. X coordinate is 2. So in place of x, place the 2. And this once you calculate, you are going to get a value of 2.601. Now, the actual value, this is the actual value 2. Now we have to calculate for actual value 2, that is residual, or also we can call it as E, the residual. In the earlier classes we discussed, it is represented as E, equal to actual y values minus predicted y value. Predicted y value is this one, actual value is this one, 2. So, just place those values. So, yi is 2 minus yi prediction is 2.601. So, it is minus 0.601. So, as we have already seen the graph, the actual point is below the regression line. So, it makes sense that the residual is negative. Yes, of course, it is negative. And in the graph also, it's showing that it's below the regression line. Our condition is satisfied. Similarly, let us, next point is 3, 4. That is x variable and y variable. Place the value of x here, that is 3, and calculate. We are going to get a value 3.83, and the actual value is 4. The residual, let us name it as R2. Why? Because earlier we have named it as R1. That is yi, actual value minus predicted value. That is 4 minus this one, 0.17. And when we see the graph, this is actually above the regression line. So it makes sense that the residual is positive. Even this condition is also satisfied. Next one is for the point 4, comma 6. Okay. Now for this 4, comma 6, place x value as 4. We are going to get a value of 5.059 and the actual value is 6. Now let us name it as R3, that is residual. Actual Y value minus predicted value, that is 6 minus 5.0. It is 0.941. Again, it is a positive sign. In the graph also, it is above the regression line. You can cross check once again. Then for the point, the last point is 6, comma 7. So this is x value, this is y value. Place the x value here. We get 7.517 and the actual value is 7. Let us name it as R4. Actual value minus predicted value, that is 7 minus 7.5. And again, we got it as minus 0.5. If you see the graph, it is below the regression line. So even this condition is also satisfied. Now, to find the residual square, we need to square each of R1 to R4 and sum them. That is sigma, this formula. Yi minus y cap whole square is equal to nothing but R1 square, R2 square, R3 square plus R4 square. So just place the values. We know this is R1, R2, R3, R4. And when you square all these values and the sum is equal to 1.542871. Okay, this is the residuals square. This is how we are going to find out the sum of the residual square. Okay. Now, we have to find out yi minus y bar whole square. This y bar is nothing but we know already it is mean. First, we need to find the mean of the y values. Okay. So the y values, y bar is sigma y by n. The mean of actual y values are 2, 4, 6, 7 divided by 4. The mean is 4.75 y bar. Now that yi minus y bar we have to calculate. That is, now we are going to calculate the summation of this is 2 minus 4.7, 4 minus 6 minus 7 minus. Okay. And when you square all this, the sum is 14.75. Therefore, the R square is given by 1 of sum squared regression by total sum of squares. That is this one. Earlier we found that the value is 1.54 divided by this value 4.75. So when you divide this, you are going to get this one. So 1 minus is 0.995. You'll get the solution. So this means that the number of lectures per day account for 89% of the variation in the hours people spend at university per day. How much variation we have to find out for this R square? This much variation we are getting after finding the residual of this one. So this is how we are going to find out the R square value, which is very important in linear regression. It is also called as the coefficient of determination. When a question comes about coefficient of determination, just we have to explain what is this R square. And if a problem comes, this is the way how we are going to solve this R square problem. Now, let me give some introduction about regression and classification. We already discussing that regression. These two, we know already this regression and classification comes under supervised machine learning technique. But what is the difference between this classification and regression? See, regression is the task of predicting a continuous variable, whereas classification is the task of predicting a discrete label. Okay. So it is continuous value. It is going to give you the discrete value. That is, data is classified it into one or more classes. Categories, when you have, it comes under classification. And regression problem requires a prediction. If you want to find out a quantity, then we are going to use this regression. And when you see the classification can be binary or multi-class. The representation will be something like this, the classification. And whenever we see regression, just simply we are going to see an x-axis, y-axis, and simply we are going to see a straight line. On that, we are going to see the data points. So this is the predicted, this regression line represents the predicted price and these data points represents the actual price. So this is what is the main difference between regression and classification? Just remember, regression is a supervised machine learning technique which is used to predict the continuous variable, whereas classification is a supervised machine learning technique which is used for predicting a discrete value. That is the difference. Okay. And from starting onwards, regression, I'm discussing you about what is independent variable and what is dependent variable. So what is this independent variable? A variable whose value does not change by the effect of other variable and is used to manipulate the dependent variable. That is called as independent variable. Often it is denoted as X. Whereas coming to dependent variable, a variable whose value change when there is manipulation in the values of independent variable, and it is also often denoted as Y. See here, there are two examples, rainfall and crop. Remember, rainfall will be always independent variable. It does not depend on anything. But when we also take these crops, yes, crops depending upon the rainfall. How much rainfall you will have this year, that much crops it is going to be yielded. So that's it. That's why this is called as the dependent variable and this is independent variable. We already know this supervised under this regression and classification. This is machine learning algorithms. Okay. And in regression, we have three types of regressions. Simple linear regression. Okay, it is multiple linear regression and then the polynomial regression. So when question comes about types of regressions, we have three types: simple, multiple, and polynomial regression, linear regression. So what is the simple linear regression is we'll have one independent variable and one dependent variable. That is simple linear regression. If you are having more than one independent variable and single dependent variable, that it comes under the multiple linear regression. That is what the difference. More than one independent variable and single dependent variable, that all comes under this multiple linear regression. And polynomial it is different. It is going to be depend upon a polynomial equation. We are going to discuss a separate class about this polynomial linear regression. And coming to the applications of this linear regression, it is used to determine the economic growth of a country or state in every quarter. And it is also predict the GDP of a country. This is one application. And housing sales to estimate the number of houses a builder would sell and at what price in the coming months based on the previous sales. Then score prediction to predict the number of runs a player may score in the coming matches based on the previous performance. And coming to the linear regression, it is a statistical model which is used to predict the relation between independent and dependent variable. It is going to examine two factors. One is which variables in particular are significant predictors of the outcome variable, means which independent variables affects the outcome variable, and how significant the regression line is to make the predictions with highest possible accuracy. So one, we have to see which independent variable we have to choose so that it depends upon the outcome variable. And other one is how significant the regression line is. That why? Because it is going to give you the accuracy of the predictions. Now, regression equation. We already discussed in the previous class. But the simplest form of a simple linear regression equation with one dependent and one independent variable is represented by y equal to mx plus c. We know that it is a equation of a straight line, that is slope, y equal to mx plus c. And when you represent it in mathematics, this is the way, this is the slope, okay? This is the c, and m is given by y2 minus y1 divided by x2 minus x1. This is how we are going to calculate the m. So y is, we know already, it is dependent variable, x is independent variable, m is slope of the line, and c is the coefficient of the line. Now, when we see this, so this is how we are going to have a regression, that is rainfall and crop. So this crop is dependent on rainfall and rainfall is an independent variable. So these are the data points, plotting the amount of crop yield based on the amount of rainfall in each year. So this is how we are going to plot. And the red point on this y-axis is the amount of the crop field you can expect for some amount of rainfall x represented by the green dot. Suppose a rainfall with this, the prediction of the crop field is this one. So this is a straight line representation. This is the regression line showing the how much crop we can predict in the coming years. Okay. So this is all about just introduction to this. Once again, what is regression and the classification. The continuation of this particular example we'll discuss in the next class. Thank you.